See Lindelof videos, geometry. Today we're going to be learning how to use properties of parallelograms. So the first thing we need to know are a few theorems. The first theorem is theorem 8.3, and it says if a quadrilateral is a parallelogram, then its opposite sides are congruent. So looking at this quadrilateral here, we can say that if PQRS is a parallelogram, then segment PQ is congruent to segment RS, or side, and side QR is congruent to side PS. So pretty simple. Opposite sides are congruent. Okay, the next one is theorem 8.4. It says if a quadrilateral is a parallelogram, then its opposite angles are congruent. So, looking at this again, we have another quadrilateral. So we can say that if PQRS is a parallelogram, then angle P is congruent to angle R, and angle Q is congruent to angle S, because they're opposite angles. All right, next one, theorem 8.5. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So again, looking at that, we can say then that if PQRS is, I'm going to abbreviate it because it's really long to write. I'll just do that, is a parallelogram, then x degrees plus y degrees should equal 180 degrees. That's simple. So Q plus R should give you 180. P plus S should be 180. Okay, and the last one. If a quadrilateral is a parallelogram, then its diagonals bisect each other. So here we have a parallelogram, and here we can see that the diagonals are bisecting each other. So we can say then that QM, which is right here, is congruent to SM, which is right here. And PM is congruent to RM. So it's saying they're bisecting each other. And M is the line here. So this QM is congruent to SM, PM is congruent to RM. Pretty simple. So now we can move on to some examples. Okay, it says here to find the value of each variable in the parallelogram. So this one is easy because we know that opposite angles, or hang on, one second. No, never mind, not opposite angles. This is an example of the angles bisecting each other. That was not phrased very well, sorry. The diagonals bisecting each other. That sounded... Okay, so this is bisecting this. So we can say here that we know that 11 has to be equal to C plus 5. To find C, we can just subtract 5. C is equal to 6, because 6 plus 5 gives you 11. And then 14 is equal to D plus 4. Subtract 4. D is equal to 10, because 10 plus 4 gives you 14. So that's pretty easy. Okay. So, for this next one, hold on 1 second. Okay. So it's simple. It says here on the last couple of theorems we went through that opposite sides are congruent. So here we have 18 and a minus 10. So we know that they, oh my gosh, following our rules, they're equal to each other. 18 is equal to a minus 10. You just add 10. A is equal to 28. So 28 minus 10 does give you 18. And then for this one, they are opposite angles. So we'll say b plus 16 is equal to 103. Just subtract 16 from both sides to find b. This becomes 0, this becomes 9, this becomes 13. 13 minus 6 is 7, 9 minus 1 is 8, 87. 87 plus 16 is 103, so that works. Okay, so then for this last one, side PQ is equal to 5 centimeters. QR is 10 centimeters. And the measure of angle PQR is 36 degrees. So we're trying to find the measures of the other angles and the side lengths. So this one's easier. This side is going to be 5 because we know that opposite sides are congruent. So this is 5 and this is 10. That's easy. And then we can do here, as you can say, opposite angles are congruent. So P is 36, so it would make R 36 as well because they're opposite angles, so they're congruent to each other. And then we also know that consecutive interior angles are supplementary. So we have to take 180, subtract 36, and then we'll find what angle Q and angle S is. So just subtract, make this 7, make this 10. 10 minus 6 is 4. 7 minus 3 is 4. Write it down. So angle Q is 144, and angle S is 144. Because 144 plus 36 gives you 180, so that is supplementary. And they are opposite angles, so they are congruent. Okay, so I hope you found this helpful. If you did, please give it a thumbs up and subscribe. Thanks for watching. Bye!